Alright, let's talk a little bit about the mount. Oh, wait a minute, let me get some wire too. Hold on a minute, guys. This is also a no-no, by the way. Zigzag is okay, but taking it to hold itself, you don't want to do that. Put a couple wire ties. Tie it loosely, not real tight, loose, you know, but yet tight enough to hold it, and you're okay. Now there's two different types of coax, and there's a number of different types of mounts. Well, there's a number of different types of coax too, but you're going to see that basically two types that is most popular and commonly used. Excuse me, guys. Let's get a new page. Start with a mount. This is what they call a stud mount. Most of your mounts, even though it may not look like this, the principle is the same. I've got a few more mounts laying around here. I'll pull a few out and show you. Now, how this works is, this was like the one I just put on my van. Well, real close to it. The one on the one on my van had an Allen key that fed through up to what they call the 3/8 24 thread. What you would do is you would drill a 1/2 inch hole, a clean 1/2 inch hole. You can't have any burrs underneath, because if you look at this, you'll see that little ring. If I can find it. See that little white ring? Come on, here we go. That little white ring right there is a nylon ring that's isolating this stud from this part here. This part here is the ground. This part here is the part that's going to end up touching metal someplace. This part here is where the ground side of the PL259 connector is going to connect to. The center part is where the center of the PL259 is going to connect to there. So this center here, this 3/8 24 thread, is actually connected to this little piece right here in the center. And that's all separated and isolated by that nylon ring. So when you plug this in, and we'll get to this in a minute, when you plug this in, you're plugging that into the center, which is the hot, because it's isolated, and this here is your ground, which is going to follow the coax, the ground on the coax, all the way up to the back of the radio, and it's going to be grounded to the back of the radio, which also, most of the time, isolates through the ground that you connect your hot and ground to. Now sometimes the boards are isolated up there, so we're not going to get into that too much. Now, so you take your 1/2 inch hole. Your 1/2 inch hole is the size of that little ring, that collar that we're seeing in there. I got to keep looking at this camera so it doesn't fog up. That little collar. Once you drill your 1/2 inch hole, this snaps down on the top into that 1/2 inch hole. This slides up into the 1/2 inch hole. That collar is connected and touching that isolator right there, which is keeping this from touching or moving around in that 1/2 inch hole and shorting out. Then you put your washer and lock washer on, and you screw this down, you snug it up nice and tight. Don't go totally nuts with it, because if you go too tight, you're actually going to start lifting this stud mount out, and that'll start pulling out, and you're actually wrecking a connector. But you want to make it tight, so tighten it. But you know, don't use a 3-foot wrench. So that's how that all works. Now, most of your parts and your antennas and your kits, you know, you're going to notice that if it's got a stud on it or not, this principle is the same. Okay, let's put it that way. So let me put this back together. Washer, lock washer, and then actually the stud, which is a 3/8 24 thread. because most of your antennas, your fiberglass antennas or your stainless steels and stuff like that, are going to have the 3/8 24 thread antenna. Now we have our PL259 connector. What's up, guys? Oh yeah, you see a little puppy? Yeah. PL259. Then we have a reducer. This is a 176 reducer. A 176 reducer is made to fit the 8X wire. Now don't go by the color. This is a clear with a copper braid, 97% shield by the way, and it's got a heavy stranded center, which is your hot again. I'm going to say hot and ground a lot, but I don't mean like 12-volt hot and ground. You know, if you touch these two together, you're not going to get a spark. Unless you're keying down on the microphone, you will blow the output transistor. And if you put a little neon bulb, sometimes you can even light a bulb. But this is what they call 8X. It's got a good shield, it's got a good center conductor, and everything is fine. I don't care for solid copper conductors in the center of small coax, because the center conductor, if it's solid, sometimes is just too thin, and if the coax starts to get bent around a lot, it's a possibility that it's going to break off. You want stranded, all right? And the more strands, the better. That's why the 8X comes in handy. This is standard coax. This is coax that normally comes with kits, you know, antennas that are all together. You know, everything comes apart in one little package. Now this actually is off of a Wilson 1000. So this is not bad wire, even though it's smaller. However, this has got a center strand, which I don't care for, a solid strand in the center. Solid piece, not stranded. And I don't care for that too much. But for the Wilson antenna, this works perfectly for it because it was designed around it. Okay, but you can see the difference in thicknesses. So the heavier one takes what they call a 176 reducer. The thinner one takes a 175 reducer because that fits into this wire. Okay? Now this one is too big, so see what I mean? We're here. Now, why do you have that? Because any good connector is made to do more than one type of wire. This is made for the heavy stuff, the RG8, the thick black wire. That's what that's made for. You would peel it back, you would show your shield, you would thread it in there, and by the time you're done, if you take the collar off, make sure the collar goes on the wire before you do anything else. Now, this would be on the wire, for instance, like this, because we don't want to make sure, we don't have to take this off again. We would pull the casing back, we would pull the shield back over the casing, the tip naturally would come through. I'll put one together so you know what I'm talking about. And when you start threading this onto the coax, you're going to start seeing in that little hole, it's 12 o'clock. There's my train. Okay, Matt, you're not the only one. I got a train too. If you can see those little holes in there, you're going to see the brass, the copper shielding inside that little hole. I don't know if you can see the black going in there. And you're going to be able to solder it from in here if you wanted to. Now, because it's threaded on, you don't have to, but it's a good idea to do. As long as you're familiar with soldering. All right, you don't want to heat it up so much that you're going to end up melting through the ice insulator. Because the antenna wire also has an insulator on it. That little nylon piece that you've seen in the mount, well, it's a little bit different on the wire, but there is a wire. So, again, with this being together and this being on there, this is made to take the heavier wire. Well, by putting this in there, it's now made to take the smaller wire. If I put a 175 reducer on there, it would take the smaller wire yet. All right. Now, there's all different types, like I say, and there are different colors. There's blue, there's white, there's black, there's clear. There's clear with a copper braid. There's clear with a silver braid. I mean, there's different types. Some like some more over the others, but basically, If it's RG8X or RG8 or Super Coax, there's all different names for it, it's okay. Because the shield is decent, it's got a good shield on it. Some shields are only like 84%, 76%, you know, 90%, 92%. Most of your 8X stuff is 97%, so that helps a lot. Now where that comes in handy is, okay, I still got some time here, on the heavier shield, I'm going to explain it to you like a garden hose. Now I'm trying to explain all this in a simple way so that the non-experienced can kind of understand what I'm talking about. Coax. And that goes for when I was showing you where to add, where to not to put it, where you should put it, how it works, the wavelength. When I talked about all that, you know, I try to do it in simple form. Is that the technical terms for everything? No. I don't want to lose anybody. I want to make it so you kind of understand. Now the wire, the coax. Picture the coax being a hose. You got your garden hose. Got a little nozzle on the front. We got water flowing through there. We turn the nozzle on. We got great pressure. Well, the nozzle and the water is the center of the coax. That's where your signal is actually traveling. Again, I'm using simple terms. That's where your signal is actually traveling. The ground is help holding that signal in so it doesn't leak out. If I was to take this hose and start putting holes in it, we're going to have water squirting out. Well, the lesser the ground, the shielding, for instance, we'll say 84%, 76%, the less it is, the less percent, the more openings are going to be in it. So the more of this signal, the water that's going out, your 4 watts coming out of the back of your radio, again we're talking legal power now, it's all escaping. So you may not see it by the time it gets to the end, or you may not see 4 watts. You're going to see, you know, maybe 2 watts, 2.5 watts, 3 watts, you know, and then if you got an SWR issue, that's going to be less yet. So we want to make sure we have a good coax. You know, if you want to do it right, you got to do it right all the way. You know, if not, buy a kit, because that's going to be your best bet, because at least the kit is kind of put together to work. As long as you buy a decent kit. You know, you don't want to, I don't know how to explain buying a kit. You know, you start buying cheap stuff, you're going to get cheap, but you don't always have to spend a lot of money either. That's the trick when it comes to a lot of this stuff. You know, some things you just have to know. K40s are a good antenna. The stainless steel, what they call a base load. Their fiberglass antennas, personally, I think they suck. Wilson 500s, Wilson 1000s, they're good antennas. Right? You buy one of those as a kit, it's going to work fine for you. They're trunk mount or roof mount. If any other kind of mount, you're going to have to kind of modify a mount to make it fit. You know, you can get magnet mounts. Magnet mounts are great. You know, you can stick it on the roof when you want it, and if it sticks, you know you got a good ground. If it doesn't stick, well, that's fiberglass. You know, it's no good for you. However, you're always dealing with the wire, you know, and the more that wire is exposed, the more problems you can have with it, because there's more chances of it getting damaged. So if the wire is tucked away, buried away, hidden, you know, less chances of it getting damaged. So let's take this for a minute. Now these strippers are old. I got to buy another half a dozen pair. I haven't bought any strippers in like 4 years. So I usually, they cost like $1.50 a piece, and I usually buy 5 or 6 pair at a time. But these, yeah, these are tough. These are the only ones I actually use. I don't like those automatic strippers. I don't like those ones with all the different size wires on it. You know, one stripper fits all. Put it in your hand. Keep your finger underneath the back, and that'll kind of work as a stop. You can use your pinky if you want, so you can kind of use it to adjust where you need it. After you do a few, you find your sweet spots, you'll know just what you need. Anyway, here's the inside, here's the shield. Now if I wanted to put this into this piece of coax, I would first put the collar on. Again, we don't want to have to worry about that. then this is going to end up in the picture. So I'm going to put that there someplace, and I'm going to figure from there to the thread about a ½ inch. I'm going to cut right about a ½ inch. Now again, these strippers been had it. I've been using them for more than just stripping wire, so this isn't going to be a clean cut at this point, as you can see. Let me take the little stray hairs and trim it up. Do a little barber work here. There we go. So now you can do this two ways using this reducer. I can either put it here, fold this down over the reducer, strip this a little bit more. I always leave a little bit right there. And what I do, you don't have to, but what I like to do, because again, I don't want the hot to take any chances of hitting the ground. I usually cut just a little piece off right here, off the casing I just took, and I'll slide that down over that. So now there's no chance of anything happening there. So now I got that. I would normally now at this point tin this with some solder, and I can take this, feed it through. Yeah, come on, let's not get cuckoo here. Feed it through, push it down and thread it on. Once I thread it on, that hole that was in there that I told you about is now, where are we? All right, is now I see that copper shielding, so I can now solder that and solder this. I want to make sure that this gets warm, and I want to keep the tip a little warm because I want the solder to flow. And so if I keep the solder iron going on the tip, it will suck in. Now again, we don't want to start sucking a lot in. We don't want to hold it up right when we do this, because then the solder is going to drip down, start melting all that shit together. We want to keep it on an angle and draw it in with the solder iron. Get a nice little ball on it. Cut this off even, all right, and so you'll be all set. Solder that. Once you're done, you can just put the collar back on. Now, that's the way that way. If you don't want to solder the shield, you can cheat. It works, but you just have to be careful. How you would do that is we take this piece that the shield that we were talking about, instead of putting it over the collar, we put it under the collar. Hey, Bear. Now this will make the collar a little bit harder to get on, because we've got to bring it down over that shield. So you got to kind of thread it down. Okay. So now the shield is under this, which means it's grounded, because this is actually part of the ground. When I screw this back into here, boo-boo-boo, get that one little strand's going to drive me nuts. When I screw this back down in here like this, I want to make sure that's tight, because this is going to be touching the ground on the radio. The center, again, is isolated by that nylon. So I want to make sure that that reducer is tight, because the shield is touching the reducer. So that's all part of the ground. Then the sleeve's going to go over all that, and then it's going to plug into the back of the radio and screw on the back of the radio, and that's how that works. Okay, so you kind of follow me so far? Now, the only problem with doing it this way is that the only thing that's holding this wire in place is the soldering of the tip, because the shield is not coming over and caught in between here and the reducer. So let me show you on paper. Here's the coax. We got that little center piece, and then we got our center. This little white piece here is isolating the center from the shield, which is here. Now I can either take the reducer, put it over. Here's my reducer at this point. Take the shield, pull it down, and put it over the reducer. So now when it comes up in here, it's going to come into a little hole on the connector, and then I can solder that. when this all goes together. Or I could take that, and again, the coax, the little center wire, I could take the shield, fold it down right back over itself, over the casing of the wire, take the reducer, slide it down right over all that. You follow me? So now it's all tucked in between the reducer and the coax. You follow me so far? Alright, I'm just going to leave this on here and solder it and leave it like it is. There's no sense me keep taking this apart because I got a soldering end on it anyway, so I'm just going to leave it like that and back it up just a hair. Alright, oh, I got to tin that first. I got to take it off anyway. Okay. So that's where we're at. So coax means a lot as well. Now for coax, you can get different types of coax. There's RG213, RG214, there's what they call hardline. And when you start getting into your RG213, 214s and stuff like that, it's actually like 100% shield. It's like double shielded in some cases because it's almost like it's got like a aluminum foil, and then it has the braided shield over that. So you're getting a better wire on some of those things. And then there's something what they call hardline. I was telling you earlier, if you start running a house antenna and you run it 200 feet in the air, you're going to lose a lot of signal through your coax. Well, with hardline you don't, because hardline is basically like the flexible copper tubing filled with foam, injected with a foam with the center conductor, which is also solid, and that is usually about the size of a pencil or about the thickness of this whole casing. Now when it comes to solid center, that's fine because you have enough of it. But hardline is something that not everybody's going to use. They use that a lot on commercial repeaters and things, or if you're going to be running a lot of power. But other than that, 213, 214, you're not going to need any more than that. Actually, you're not going to need any more than your 8X. So, all right. So I hope that helps some of you guys so far.